So let's go ahead and work through problem 9. We're going to start with A. I don't want to write in a highlighter. Pink. So I have sine of alpha minus beta over cosine alpha cosine beta. So the first, and that's going to equal tan of alpha tan beta. So for problem A, I have that. I'm going to rewrite that numerator using our sum and difference formula. So I have sine alpha cosine beta minus cosine alpha sine beta all over cosine alpha cosine beta. And then I want to pull that fraction apart. If you haven't seen the bonus episode of how to solve trig identities, I would take a look at it. It's pretty great. But one of the tools that we have in our toolbox is pulling our fraction apart. So I have sine of alpha cosine alpha over cosine alpha cosine beta. Minus cosine alpha sine beta minus cosine alpha sine beta over cosine alpha cosine beta. And what you're going to see here is that my cosine betas cancel and my cosine alphas cancel. So I am left with sine of alpha cosine alpha minus sine beta cosine beta. Well, sine of theta over cosine theta is tan. So I have tangent of alpha minus tangent of beta. So that's the first one. For part B, I have tan squared x minus sine squared x. And what I'm going to do is I'm going to use that trick where we rewrite tangent as sine of theta over cosine theta. So that would give me sine squared theta, well, we'll say x, I don't know why I was saying theta, over cosine squared theta minus sine squared theta. What I can then do is go ahead and write this as a one fraction. To do that, I'd need to multiply this by cosine squared theta in the numerator and the denominator. That gives me sine squared x minus sine squared x times cosine squared x over cosine squared x. I'm going to go ahead and factor. I'm going to factor out a sine squared x. Well, that gives me sine squared x over cosine squared x. Well, I know that 1 minus cosine squared x is sine squared x. So I'm going to have sine squared x over cosine squared x times sine squared x. Oh, see, we're like halfway there. I just need to rewrite sine squared x over cosine squared x as a tangent. So I'm left with tan squared x sine squared x. I am going to go ahead and clear us a little bit of room. Oh, there's even more problems. Okay, I'm going to go ahead and clear a little bit of room for this last one. It is going to take up quite a bit of space. So yay, I deleted it. That didn't work as well as I wanted it to. Well, we learn. We learn. All right, so for part C, I've got cosecant of theta plus tangent of theta plus cotangent of theta over tangent of theta plus sine of theta. First thing I'm going to do, I want to rewrite all these in terms of sine and cosine. Cosecant, 1 over sine theta. Cotangent is cosine of theta over sine of theta. Then I've got tan of theta, which is cosine theta over sine theta, plus sine theta. And I want to go ahead and combine my numerator and denominator, so I have one fraction. So that's going to give me 1 plus cosine theta over sine theta. All that over cosine theta tangent of theta is sine of theta over cosine theta. So I have sine theta over cosine theta plus, if I was to write this, I'd need to multiply it by cosine in the numerator and the denominator. So I have plus sine theta cosine theta. Then I can go ahead and factor out a sine theta. So I have 1 plus cosine theta over sine theta. Then I factor out a sine theta, so I've got sine theta times 1 plus cosine theta all over cosine theta. Now I keep my first fraction the same. I change from division to multiplication, and I flip the second fraction. My 1 plus cosine thetas cancel. So I have cosine theta over sine theta times, sorry, I have 1 over sine theta times cosine theta over sine theta. Well, that is cotangent. And this 1 over sine theta is cosecant theta. And because we're multiplying together, I can rearrange the order.